Now let's try the last topic of limits is about the special limits. So when limits, so here are some of the special limits wherein example is the limits of sine x over x wherein x approaches to 0. This is equal to 1. And then the limits of 1 minus cosine x divided by x equals to 0. Then the limits of x approaches to 0. Oh no, limits of tangent x divided by x wherein x approaches to 0. This is equals to 1. So the limits of x, 1 plus x raised to 1 over x wherein x approaches to 0. This is equals to e. So now, if we're going to analyze the equation, if so in this kind of problem, sine x over x wherein x approaches to 0 equals 1. So if our value for, so if we have, so the same also if we have the limits of x approaches to 0 wherein sine of 2x over 2x, this is also equal to 1. So don't forget this kind. So don't get confused. So sine 2x over 2x is also equals to 1. So just observe that what you need to do is the angle here is just the same in the denominator. Okay, so if we have sine 2x over 2x, this is also equals to 1. So if we have sine 3x over 3x, this is also equals to 1. Okay, so if we have sine 4x divided by 4x, this is also equals to 1, wherein the x approaches to 0. Okay, again, so this is so sine 2x divided by 2x wherein x approaches to 0 is also equal to 1. So just observe that what you need to do is just the angle of the sine, and then the denominator must be the same. So that's the how special this kind of limits. The next one, so in tangent x divided by x wherein x approaches to 0. So the same also if we have here 4x, then 4x, so 4x, so the same also that our result is it is approximately equal to 1. So the x here, or the angle for the tangent and in the denominator must be the same. So the same also here. The so if we have 2x in here, so also our denominator must be in 2x, so that you could said that it is under the special limits. So we can say that 1 minus cosine 2x over 2x equals to 0. So that is how special again this kind of limit. So do not forget this one. So now let's try some examples. So if we are going to evaluate the limits of sine 4x divided by 3x wherein our x approaches to 0, we are going to use the special limits. Okay, so in this kind of problem, what we need to do, our goal is that the 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 angle for our sine and then the denominator must be equal. Okay, or we need to find everything that the angle for the sine and then the denominator must be equal, or they are distinct with each other. So at this point, so if we are going to try this kind of problem, so the limits of x approaches to 0. So let me try this one. So sine 4x divided by 3x, so they are not equal, so we need to find something. So what if I try to multiply it by 4? Okay, so that so let's try muna this one. So we know that 4 sine 4x times 4 is, this is 4 sine 4x, sine 4x. Okay, divided by 4 times 3x, this is 12x, or we could say that this is also 3 4x, right? Now, based on our example, so we multiply 4 divided by 4. So now our sine 4x divided by 4. So we have we there is now an distinct. So the sine of or the angle for the sine is now 4x, and then we can have also 4x. So diba, based on the problem kanina, so sine 4x, so the limits of sine x divided by x wherein x approaches to 0, this is equals to 1, or sine 4x divided by 4x is approximately equal to 1. So this is it. So therefore we could say that uh, so the limits of 4 sine 4x divided by 3 times 4x. So again, our sine 4x, or the limits for, or okay, let's try this one. So the limits, so we x approaches to 0 times 4 divided by 3, so times the limits of sine 4x divided by 4x. Okay, so just review the theorems of limits. So this is under the product theorem. So therefore we could say that, okay, so now we know that the limits of sine 4x divided by 4x is also equals to 1. So as stated in the special limits. So in here, okay, so now our answer is already, so since wala na siyang x, so therefore wala na tayong i-substitute sa kay x. So our answer is already equal to 4 over 3. So this is our answer na. Okay. So our next problem for this kind of function, we need to evaluate the limits of 2x minus 1 plus cosine 4x divided by 5x, wherein x approaches to 0. So at this kind of example, what we need to do is just, so our goal is to find something that might be in connection with these ones, or the limits the limits x approaches to 0, our function natin is a 1 minus cosine 2x. Cosine x divided by x is this is equals to 0. Okay, let's try. So in our given, so we need to derive first this kind of equation. So this is just equal to the limits of x, the limits of 2x divided by x, 5x I mean, okay, so plus the limits of 0, no, the limits of negative 1 plus cosine 4x divided by 5x. Okay, so in here, so what we need to do is, so this is already, so in the first term we cannot apply the special limits here because it is already we can find the, or it is not under the indeterminate form. So again, let me remind you everyone that special limits is only applicable if the function is if the output is in the indeterminate form. So in the previous problem that we had in the in this kind of example, so the sine 4x over tx, so sine 0, so sine 0 divided by sine of 0 divided by 0. This is already an indeterminate form, 0 over 0. So again, you can apply only the special limits when the output is in an indeterminate form. So that's how it is. So in this kind of example, so if you are going to check, so try to check at yourself that 2x minus 1 plus cosine 4x divided by 5x. This is already an indeterminate form because if you are going to substitute the value for x to 0, 5 times 0 is 0. So any function divided by 0 is already an indeterminate form. That is why we need to use the special limits. Again, special limits is only applicable when you are arriving such indeterminate forms. Okay, so next step is what our goal is 1 minus cosine x. So we need to, let's try, let's copy this one. So this is already equal to 2 over 5. X is cancelled. So 2 over 5. So x approaches 0 is not already applicable. So let's revert the sign. This will become minus, and then the negative 1 will become positive 1, and then the cosine, this will become minus cosine 4x divided by 5x. Now in this kind of example, what we need to do is we try again to use some kind of multiplier that might be uh, goes or the same like this in our special limits theorem. So based on my observation, so what we need to do is the angle of our cosine and then the value for here in our denominator but must be equal. So I think we need to multiply by 4. So the technique here is what is the coefficient or the coefficient of the angle, or let's say 4x. So cosine 4x, so you need 3x 4x here. So oh no, if this is cosine 3x, so you need 3x here. So you need to multiply 3 divided by 3. So if it is cosine 4x, um what you need to do is multiply it by 4 divided by 4. So if it is cosine 5x, multiply it by 5. So it depends on the value of the angle inside the trigonometric function. So cosine 4x divided by 5x, so we need to multiply it by 4. 4 over 4. Okay, so that we can say that negative 2/5 minus, so let's try this one. So this is already equal to 4 times 1 minus cosine 4x divided by 5 times 4x. Okay, so at this point we could say that this is already under the special limits, that 1 minus cosine x divided by x, or in x approaches to 0, this is already equal to 0. Okay, so therefore we could say that this is 2/5 minus 4 over 5 times 0. So therefore we could say that our answer, so this is already under the limits, kasi may limits tayo dito, limits when x approaches to 0. Okay, so again let's review the special limits. Okay, yes, here it is. It is equal to 0. So therefore we could say that our answer would be equals to 2/5. Therefore, the limits of 2x minus 1 plus cosine 4x divided by 5x, wherein x approaches to 0, our answer is equals to 2/5. The last one. We are going to evaluate the limits of 5 e raised to 5x minus 1 divided by x. So again, let me add this kind of special limits, or some of the derivation of special limits. So the limits of e raised to x minus 1 divided by x, wherein x approaches to 0, this is equals to 1. Okay, okay, sige. So first, let us try. So again, based on the statement that I had shared to earlier, that the special limits is only applicable when our given is in indeterminate form. So based by inspection, we can say that this is already an indeterminate form, because when you substitute x by 0, automatic our denominator is 0. So if we can say that this is 0 over 0, or any variable divided by 0, or any constant divided by 0, so it means automatic any constant or variable divided by 0 is an indeterminate form. So we need to use a special limits. So in our example here, so our goal is just to find something that might be in familiar with e raised to, or the same with e raised to x minus 1 over x. So this is also the same with e raised to 2x minus 1 over 2x. So the same also is, it is equal to 1 as long as it is approaches to 0. So here we need to find, our goal here is just to find the denominator must be in 5. So again, the same technique kanina, what we need to do is, if what is the, so in the previous example, we tried to multiply it by 4 because the we need the 4x in the denominator. So in here, since this is already 5x, so we need to multiply it by 5. 5 over 5. 5 over 5. Okay, sorry, just neglect this one. So therefore we can say that our the limits of this is, so this is 5 times e raised to 5x minus 1 divided by 5x. Yan. So therefore, there is already a distinct that e raised to 5x minus 1 divided by 5x. Okay, so this is already equal to 1. So e raised to 5x minus 1 divided by 5x, wherein x approaches to 0, so this is already equal. So if we're going to use the, so let's step-by-step method. So let's try this one. Limits wherein x approaches to 0 to 5. Okay. Five, and then the limits wherein x approaches to 0 times e raised to 5x minus 1 over 5x. So this will become equal to, this is already equal to 1, therefore our answer is 5. Therefore we could say that the limits of x raised to 5x minus 1 divided by x, using the special limits, we multiply it by 5 divided by 5, so that this special limit is applied in this kind of equation, so therefore our answer is positive 5. So